beyond apps and smartphones, unleashing STEM potential for a sustainable, resilient future. Over the past 2 decades, engineers have expressed concern to us regarding the lack of opportunities to address pressing issues across multiple sectors. A prime example is our continued reliance on gas-powered cars, a technology that has been around for over a century. The focus on progress seems concentrated in specific areas like mobile apps and smartphones, which are not built in North America, often overshadowing other critical sectors, including construction and transportation. In contemporary construction, there is a growing interest among STEM professionals in returning to the fundamentals by utilizing materials such as solid wood, glass, and concrete. This is how new commercial university buildings are built. This approach is not only aesthetically pleasing, but also valued for its sustainability. For years, homes have been built and continue to be built with perishable, low-quality building materials. Houses could be replaced by more resilient and cost-effective commercial code materials, contributing to both sustainability and durability. Of course, this great scenario is all ought to hope for, given that it is not certain that houses will even be permitted to be built in the future, as the current degrowth policy to continually create urban zones instead of rural zones, to continually create small condos instead of houses. And this is what we see in the non-STEM and degrowth strategy being employed to address climate change. Since the 1970s, Western societies have not progressed across multiple sectors of the economy. The lack of advancement in the real-world environment and an analysis of all of the sectors make this apparent. For instance, the issue of homelessness in cities like Vancouver highlights the general lack of progress. There appears to be a concerted effort on a policy level within North America to restrict carbon emissions by limiting industrial production and inhibiting the development of advanced industries and equipment. As a result, STEM professionals lack the necessary tools, equipment, the necessary knowledge base, the necessary practice, and the necessary community size and infrastructure to develop efficient, clean energy systems and low-energy products, impeding their ability to tackle global climate change problems. The question remains whether the strategy of slowing down technological and industrial progress in North America and Europe has truly benefited the environment. Studies have shown that carbon limitations correlate with reduced income and limited business development. The fewer machines that are allowed, the fewer businesses that are required, the fewer workers that are needed, and the fewer solutions that are developed. Implementing carbon credits, which can be viewed as another form of financialization, may increase revenue growth for carbon credit holding corporations in the future age of deflation caused by demographic decline, but could reduce the standard of living for individuals and the development of businesses, both of which will be constrained by carbon limitations in the near future. This approach focuses on financial instruments rather than tangible, real-world upgrades to create a sustainable and technologically advanced society. In the construction industry, STEM professionals tend to prefer durable, lasting materials in home construction and commercial code standards. This aligns with their focus on sustainability and efficiency. Durable and sustainable home construction, incorporating materials like concrete, wood, and glass, represents ongoing value, much like non-perishable commodities such as gold. Building in this manner reflects a commitment to resilience, sustainability, and durability while adding and retaining value within a society for a very long period of time. Incorporating STEM professionals into decision-making processes and providing them with the necessary resources to influence urban development and transportation systems will contribute to a more sustainable and energy-efficient world. As another example, by redesigning cities to prioritize public transportation over personal vehicles, clean energy sources such as solar or wind can be harnessed for buses, trams, and trains. This approach not only alleviates traffic congestion, but also substantially reduces carbon emissions, promoting the adoption of lightweight electric vehicles instead of standard weight electric vehicles, further mitigates waste and environmental impact. The current reliance on 5,000-pound vehicles to transport 150-pound individuals is not indicative of an efficiently engineered system. How can society deploy advanced lightweight materials if the policy of the North America is a degrowth policy of a 20th century material use constraint? Something akin to an ultra-lightweight vehicle design, 75-pound to 500-pound vehicles that can transport 150 pounds individuals is an engineering goal worth pursuing and deploying to the real world. A continual focus towards degrowth policies will lead to inefficiencies, but embracing an unconstrained technology sector and welcoming STEM professionals into policy analysis roles can initiate the process of integrating STEM methodologies within the societal framework. This will ultimately address and rectify the issue of excluding STEM techniques from the cultural fabric within the North American environment. STEM professionals could spearhead the development of green infrastructure, such as bicycle lanes and pedestrian-friendly streets, promoting healthier and more sustainable lifestyles. Integrating green spaces and efficient waste management systems into city design would create energy-efficient urban environments that also promote well-being. Furthermore, advances in renewable energy technologies, such as solar panels and wind turbines, could be integrated into city infrastructure and building design, ensuring a sustainable energy future for all. Government policies and investment could support such innovations, helping to tackle climate change and create a more resilient, environmentally conscious society. In conclusion, incorporating STEM professionals into the political sphere can lead to tangible progress rather than relying solely on financial instruments such as carbon credits. By doing so, we can create a world that embraces advanced technologies, embraces a clean and modernized 21st century industrial and energy systems design which could replace the traditional industrial sector and energy systems designs of the 20th century, and fosters sustainable and action-oriented culture that has the large-scale engineering capability required to solve large-scale problems. By re-evaluating our approach and valuing the expertise of engineers, technologists, and computer scientists, we can empower society to address the pressing challenges of our time, from climate change to resource scarcity and beyond.